The Airfinity S. This is the new baby born. It is going to complete the range of air-to-air rooftop units. Until yesterday it stops at around 40 kilowatts, but now with this unit we can go down to 16 kilowatts. So this range in this shape will cover a range from 16 to roughly 40 kilowatts of cooling capacity. We started the project considering the retrofitting of the old Voyager 1 and 2 rooftop units we have sold in the past. So in particular, the basement of the unit fits exactly on the roof curb of the previous Voyager 1 and 2. So ideally, you can just remove the old unit and place this new one, and it fits exactly on the shape of the old roof curb. What we add on top of that, let's start from here. You see the double staging of filter. So you have a possibility to add up to F9 filter as an option on this unit, and there is a space for that. You can have, as for the previous Voyager 1, the return from the bottom or the return from the rear of the unit. And you can have the supply on the other side, so you have horizontal side discharge, or you can have also downflow discharge. We introduced as a standard the plug fan. You see that it now is mandatory due to the ERP regulation. So for the eco design to have a very efficient unit, we need to use the DC plug fan. And on top of that, as you can see, we introduced the 25 millimeters thickness on the panel to grant a proper thermal insulation on the unit. Please consider that we insulate also the corner of the unit, so also the corner are insulated, so no thermal bridges, and the unit is very well insulated, considering also the small range we are considering. We have the AFD compressor moved with the inverter, and the fan is also EC. So everything in this unit is electronic commuted. We have an actual EC fan, EC compressor, and the EC plug fan. This is the basic unit for all recirculation, but you can ask to have the unit with the economizer. In this case, in this position, we introduce a damper, as you can see from this image, plus a rain hood to cover, to avoid that water falling into the unit. And this way, with a very tight footprint, within the same footprint of the unit actually, we can have the unit also with economizer and free cooling, of course, that is coming. And also in this case, very important, we don't change the position of the return opening for the air or the supply opening. So the unit remains the same, the footprint is the same, the roof curb is the same. So you can still adapt it to the roof curb of the old Voyager 1 and 2. But if you want something more, if you want to save some energy coming from the exhaust air, you can ask the unit with thermodynamic heat recovery. So what we are going to add? On the back of the unit that is in this position, you will find a box with an exhaust plug fan. This fan is going to extract part of the air, and this extraction is extracting in proportion to what is the amount of fresh air that is flowing into the building. So in this way you can have a counterbalance of the air that you are introducing, so you don't create overpressure or underpressure inside the building. But the idea is that exhaust air that has some energy, considering the surrounding ambient, instead of letting it free through the air, we are pushing it through this duct that will be assembled on site. And this duct will move the air, the exhaust air, in front of the outdoor coil that is on the other side now. So you create an overpressure thanks to this duct. You have an underpressure in front of the coil because there are the fans that are sucking the air from the outside. So in this way you are creating a milder temperature around the coil, so granting better condition for the unit to work. So it comes that you have an higher ER, an higher COP, and you can have also some cooling more because the operating condition is better than the surrounding air that is around the unit, thanks to this recovery. Very easy, very simple. So the idea is that the return on investment is also pretty low.